Hi everyone, and welcome to the new episode 3, Categorical Variables. And It's been a while since the last episode. It's because I've been quite a lot busy, but that also means I'm going to have some really cool videos for you guys in the coming days. And I've tried a lot of new things like training models on TPUs, and I'm going to explain you in some short tips and tricks videos how to do that. And um, since I was also requested to have a cup of tea, so here it is. Um, in this episode, I'm going to talk about categorical variables, and I've seen this quite a lot of times in the industries, like even people with a lot of experience and PhDs and stuff, they are not able to handle categorical variables, and it's not something really very different. There are just some tips and tricks on how to handle categorical data. So in this video, I'm going to talk about what different kinds of categorical variables can be and how you can handle them in a very easy manner and build models based on that. So everything that I am doing in my videos, I'm doing it from scratch, as you can see. So there is no script. So there will probably be a lot of mistakes, but we will figure it out. And there will be a couple more videos after this one regarding categorical variables, because it's not possible for me to fit everything in one single video. If I do that, the length is going to be huge. Um, so let's start with categorical variables and see what the different types of categorical variables are. So categorical variables can be majorly divided into two types. So you have categorical variables, and the two major types are nominal and ordinal. So nominal is all kinds of categorical variables which are like two or two or more different types in it. And ordinal are categorical variables that have a fixed kind of order in it. So let's say you have data about salaries, and there are three different levels of salaries, like low, medium, and high. So this becomes your ordinal variable, and nominal will be like if you have um, the sex of the person, like male or female, for example. So this becomes nominal variables. Now, to me, all the categorical variables are the same and can be handled the same way. So, uh, to to start with this, I would first need some kind of data, and that's what we have been doing. So, we just take a data set and then try to approach the problem. So, let's see if we can do that. Uh, so, we are lucky that we have an ongoing Kaggle competition with categorical data. So let me see if I can find it. Yeah, here it is. And I discussed this in one of my previous videos, but I discussed the old version of this competition. So today we will see, okay, the new version, which has more categorical variables. So this data consists of binary features, nominal, and ordinal features, and there are some cyclical features like day of the week and month. So let me just quickly download this data. Okay, so I have downloaded the data, and now we can start working on it. So my data should be in input. So I downloaded it as train underscore cat, and it's looks like it's a huge data set. Yeah, so you can see there are many different kinds of variables in it. So I would try to first see what they look like. And for that, I would use something that I don't generally use. So I'm going to make a new folder called notebooks. And inside that, I'm going to start Jupyter. So let's see. Okay, so we don't have anything here. Well, let's create a new Python 3 notebook. And I'm just checking what the different kinds of variables are. So we need pandas, and we need to read the data frame. So p dot read CSV, and here we have input train underscore cat dot CSV. Let's see. Okay, so that was quite fast. So let's see what the different data. Okay, so you can see like, okay, it has binary variables, bin underscore the number, and nominal and ordinal, and you also have day and month. So now we can just check. So like if I do df bin underscore one dot value counts, so it's going to give me all the different types of values that this column has. So it has 0 and 1, and it's a binary column. So if you check something else, bin 4, yes and no, hopefully. And same thing you can try for nominal. So nom underscore 0, let's say. It has 3 different categories: red, green, and blue. And if we check ordinal, one of the ordinal variables, what we have here, 1 2 3, so probably like 3 different levels as I talked about. It has an order. So this one seems interesting, so let's see this one. Okay, yeah, so now it's more intuitive. Different levels of temperature. Okay, and hopefully then you have day and month, so we can also check that. df.day.value counts. So you have days of the week, and a month will have 12, but just for the sake of checking it. Okay, so month, yeah, that's 12, hopefully. So there's not much exploration that you want to do with this data. You can see like, okay, some values appear much less than others, and yeah, that's quite possible. It might also be possible that there are some categories which are in the training set that we have downloaded but not in the test data. So how to handle that? And even though count is like quite less, for some of them it's not like they appear only 10 times, so we don't have rare values. uh, okay, so back to our workspace. So we created quite a lot of files. We created a class for cross validation, and we're going to do something similar today. We're going to create a class for categorical features. So in future, whenever you have categorical features, you just need to input what kind of processing you want, and you're done. Categorical features dot by, or should I just call it categorical? Okay, and there are many different ways of handling categorical data. And let's see that first. So there are many different ways you can handle categorical data, and let's look at this data here. Okay, so this is my ordinal column, and what we want to do here is know the number of different ways. So we have freezing, and then we have warm, cold, boiling hot, and we have hot and lava hot. So one very basic simple way to handle categorical data would be to just represent them as numbers. And if you represent them as numbers, what you have 0 for freezing, let's say, then 1, 2, 3, 4, and 5. Another way to represent, so this works, and most of the times it just works. So you represent them as numbers, and then you throw a model which works on categories like random forest model, or you extra trees or XGBoost, like GBM, all kinds of tree based models. You don't need to care about categorical variables more than this part, so this is called label encoding. That is, you encode all the categorical variables to a certain kind of label. And then what you can do is you can um, represent them as binary variables. So if you have many different levels of data, they can be represented as binary. So what would this be in binary? 0, 0, 0. If we take 0 as like the from the label encoding, and then you have 1, so this can be represented as 0, 0, 1. Then this one can be represented as 0, 1, and 0. This is 3, so 3 can be represented as 1, 0, 0. No, sorry, 3 is 0, 1, 1. And then you have 1, 0, 0, and this one will be 1, 0, 1. So we have represented them as binary, and sometimes you need to represent them as binary variables. And this is mostly when you have data in ordinal format. Another way to represent this would be to do one hot encoding. And in one hot encoding, what you do is you have a vector which is of the same size of the number of different levels that you have. So I think this is the same size. And then let's say this is 0-bit, right? So you put 1 here, and all these others are zeros. And similarly for others, it's like, okay, you have only 1 bit which is 1, and rest others are 0. So this all is 0, and this is 1. And for this one, you will have 2, 3, 4. This is 1, and all others are zeros. So you can see, like, in one hot encoding, you have less number of ones than binary encoding, and that's sometimes good, because what you want to do is, what you have here is 1 2 3 4 5 and 1, and then you have 0 0 1 0, then you have like this 0 1 0 0 0 0 1 0 1 1 1, sorry, 0 0 0 0. So your data looks like this actually. So you have converted the 6 different levels to 6 new features. 1 2 3 4 5 6, and all of those features are binary features. Now, why this is a better way? Because you can see this, this consists of very less number of ones, so it can be represented as sparse matrix. And when you have tens of thousands of categorical features in one column, different kinds of categories, representing them in a binary form would require more memory and space than representing them in sparse format. And once you have this sparse matrix, you can also use simple models like logistic regression. So what we are going to do is, we are probably going to avoid binary and convert everything to one hot encoding or label encoding. So going back to our data set, this data set has a lot of different variables. It has a ID column, and then you have a target. So this seems like a binary classification problem. So let's see if this is, yeah, okay, this is binary classification problem, and it seems like, okay, kind of like 20% of the values are ones, the rest zeros. So uh, how would you start coding with this? Now I want things to be like very generic, so we have uh, let's see what we have to do in this code. We have different ways of handling label encoding. And then we have um, one hot encoding. We can probably add binarization. And then I will add some more things here as we progress. But for now, we start with making a class. So I say the class name is categorical features. And what should the class expect as its inputs? So we have to define an init function, and what kind of input do we want? Do we want a data frame, or do we want some kind of process data? So let's say we just want a data frame, and we want to know beforehand what categorical features are, and encoding type. So we want to know all these things. So I will just save them self dot cat feeds, like categorical features, and self dot encoding type is my encoding type. Now here you have to note that df is the pandas data frame, categorical features is a list of features. So here you have odd 1, norm 0, these kind of features. List of strings, list of column names. And you have encoding type, which can be like which can be for us can be okay, label encoding. So I will say label, binary, and one hot encoding, OHE. So I will build some functions that do these different kinds of encoding to the data. So we have def, and I'll say this is my label encoding function. So what this function should do is it should take the data set as input and different kinds of categorical variables, and then convert all those different categories to numbers. Do we need anything else here? So we have everything. I think we have everything. Or probably we can do fill NA values. Okay, let's look at that later. So if I search for label encoding, you have scikit-learn, and scikit-learn offers you a label encoding class. So you initialize the label encoder, you fit the label encoder to some categorical variables you have, and then the transform function will transfer it to label encoded values. So you see here you have 3 different levels, 1, 2, and 6. You fit them, you fit the label encoder here on 1, 2, and 6. So you have 3 different classes, and then you transform them. So you are left with 0, 1, and 2. So if you have 1, 1, 2, 6. So 1 is 0, 2 is 1, and 6 is 2. And you can also do inverse transform on it. So what I'm going to do is, yeah, and it also works when you have strings. So I saw something here, and you can see like bin1, bin0 has some NA values in it. So I just want to check if my label encoding will work with NA values. So from sklearn import preprocessing, and then what I'm going to do here, I'll say okay, this is where I initialize label encoder class, and I say dot fit on bin0. So if I have to fit it on bin0, I have the data frame, column name, values. Right. And it works perfectly fine. So df.bin0.values, we already know that it has nan values in it. Well, you can see, hopefully, yeah, see, you have some nan. So now if we do transform df dot bin underscore 0 dot values, now it throws me an error. So you can see like it fits perfectly, but when you have nan values or inf values, it's going to throw you this error. So what you want to do is you want to fill the NA values in it. So let's say I know that I have only zeros and ones, so I fill NA with -1 and then F it. And when you transform it, you're going to use the same for NA values. Oh, sorry. Okay. It has to be here. And then it transformed perfectly. And to list, here you see the fourth value is -1, the NA value. And here also we can see, no, fourth value, NA value has been assigned 0. So we want to handle NA values here, and to handle NA values, should we leave it to the user to decide whether he wants to handle NA values? Let's say we leave it for the user. So when you input the data frame, it has to have no NA values in it. And then we will import from sklearn import preprocessing. Or you can say like, okay, handle NA to false. I will say, okay, if I want this class to handle NA values, it can handle NA values. And then NA can be true or false. And what do we need to do here then is we have to go through each and every categorical features. And say, okay, I have to handle NA values. So the best way to handle NA values would be to just convert everything to a string. So self.df and so I chose the column name C, and then I do this. Just take this part from here as type string dot fill NA with some imaginary value. Now you have to be careful here. If like this value you're choosing is already in the dataset, then you have a problem, but hopefully nobody puts a value like that. So now you have adjusted your data frame. So what you do in label encoding, you have a label encoder class. So preprocessing dot label encoder, and then you fit it on the column. So to fit it on the column, first you have to go through all the columns. So for C in self dot categorical features, define a new label encoder for each and every of them, and I will define here self dot label encoders is a list. Okay, probably not a list. Let's make it a dictionary. So you have this, and then you say, okay, lbl dot fit self dot df dot self dot df column name dot values, and let me create a new data frame, self dot output df, which is self dot df dot copy deep equal to true. So this one just makes a deep copy of the data frame, so you don't have to so when you change something in the original data frame, this output df does not change. So we fit it on the original data frame, and then we say self dot output df dot lock c is will be lbl dot transform self dot df c dot values. So now we have transformed a single column, but why did we make this? We made it to save our encoders, because in case we want to do some kind of transformations later, we want to save it. So I will say, okay, for C, this is LBL. And I think you're done with the label encoding here. So every values has been label encoded. So we make another function called transform function. We can also input the data frame in the transform functions, but I would like to keep it just here. And then you have then you can say, okay, if self dot encoding enc type equal to label, then you call the label encoding function self dot label encoding. And do we want it to return anything? Let's say we wanted to return the output data frame, so we have something, right, to see. Return this elif, else you can raise an exception saying encoding type not understood. So till now we have implemented only one label encoder. So how I want to test it, I'm just going to test it here. I say, okay, if I'm calling the main function, calling the script. So what we do is my df would be pd.read csv, and I don't have pandas imported. Do I need to import pandas here? I don't want to import pandas like for everything, so I'm just going to import it here. pd.read csv. Now it's in my input file /input/train underscore cat.csv, and then I say cat feeds is equal to categorical features. You have the data frame. It also needs the column, right? Okay, now this data frame has everything. It has ID column, it has target column, so we don't want to encode them. We only want to encode the categorical features column. So for now, I'm going to say columns is all columns in df.columns if column name is not in ID and target. So we can also see this, what we get here, and here df comma, what was the variable name, categorical features. Okay, so we need to fix this part. So if handle NA, then only you need to do this thing, otherwise you don't care. Categorical features is columns, and then we have the encoding type, I believe. Encoding type will be label, because we have not implemented anything else yet, and handle NA to true, because I already know that we have NA values. And my output df is cat feeds dot transform. So let's see now. Print output df dot head, and I can just run it. So let's see, let me adjust this. I would rather not run it here. I'll keep it as a empty space for more tips and tricks. So this looks good. Can start a new terminal here, and it has already activated my machine learning environment that we created. So let's get rid of that, increase the space a little bit. And what do we have here? Okay, I need to go into this folder, and then I just have to run categorical features. Do I not have it there? Did I create it some other place? Okay, so I created it at a different location. Let me just move it. And I should have it here now. Okay, it's there. And I just do Python categorical. Let's see. Okay, yeah, error, obviously. C in df.columns. No, and that's a wrong syntax. So it's going to be C for C in df.columns if C not an ID or target. And let's see what we get. So it prints all the columns that I have. Now it's taking a while, and that's pretty obvious. It has to take a while, but now you can see that it has converted everything. It has left like ID as it is and target as it is, but it has converted everything else. So if you remember, bin 0 had this too. So we can also try it in Jupyter, but we won't for now. We'll do it later. So So now we can move to the next type. Actually, we can move to binarization, or we can move to one-hot encoding. So label encoding, we're done. So we now move to binarization, then we can move to one-hot encoding. So let's see label binarization now. So in binarization, you're basically creating a lot more new different columns, right? So binarization, for binarization, you also have uh, module in scikit-learn. Okay, so this is something I didn't know. I can probably take a look at this one. Encode categorical features as an integer array. So you have ordinal encoder. Yeah, okay. We don't need that. So label binarizer. And binarize labels in one versus all fashion. Is this what we are looking for? Yes. So this is what we are looking for. And binarization should be done in the same way as we did the label encoding. It's just that in binarization you have a lot of different columns, so we need to handle them. So I say okay, label binarization, and what we have here is okay, go the same way for C in self dot categorical features, and then we will just name it LBL pre-processing dot label binarizer this time, and it goes in the same way. So I'm just going to take this part from here and copy paste it here, and then it's a little bit different here now. So val, okay, this will be this will probably be a numpy array. Let's take a look how it works. Label binarizer, then I've fit it on this one, same, and okay, I don't need this one anymore. And then let's see what it does. Okay, yeah, so it's like taking the data frame, but it's creating uh, three new columns, right? Okay, so go back to our code. So val here, if you do lbl dot transform, same self df dot values, val is a array, many different columns. So what you have to do now is remove the column that you fit label binarizer on and replace it with three new columns. So I will say okay, for j in range val dot shape 1, what we have here is a single column now. So but before this, let me just say okay, my data frame self.df is self.df.drop column name access 1, and now new column name will be something something that we can know. So um, like in this data set, all the binary columns are called bin, but we have no other choice. So I'm going to say it's this column name plus underscore underscore, and let's make it a f string, and j underscore underscore bin underscore j. So your new column name will be the original column name plus two underscores underscore bin and the number. And self.df. Now you have to make sure that no column name like that exists in the original dataset, but it's the probability of that happening is quite low. Self.df and new column name will be val all rows and jth column. Okay, so did we do something wrong here? Yeah, we did. So we need to use the output df, not the original data frame. So we drop from output, and this is also output. And I think this function looks fine now. One more thing here is you need to create another dictionary for binary encoding. Let's call it self.binary encoders, and that's another dictionary for you. And you say self.binary encoders, column name is your binary encoder, and return self.outputdf. And now we have to see if this works. We don't need the comment anymore. So we are going through each and every categorical feature, and then we are initiating a label binarizer class, fitting it on the column, then transforming it to an array, and then you have the output data frame where you drop the column, and then for every column in this val array you create a new column name and add it to the output data frame, and then in the end you save the encoder. I hope this works. So to run this we need another if and call it binary self dot score binary. What do we call the function? Oh, we don't. Label binarization. Okay. Label binarization. Then this should work fine, in my opinion. Can try it. So where's my terminal? Let's see if this makes sense. It's probably gonna take a while. Okay, so it doesn't work. Oh, transform. It should be fit underscore transform. Yes. Okay. Hopefully it's not taking a very long time. No, it's not. So what does it print for me? It doesn't look like it worked. So you have the column names, that's fine. You have all these things here. And should be binary, but I don't see them as binary, so something weird has happened somewhere. And so we have fit transform, encoding type is binary. Oh yeah, we didn't change the encoding type here. Now we run it again. Let's see how much time it takes now. So till it finishes, we can take a look at one new function, and I'll call it transform function. So I've already written this function. No, I don't usually do that. So you have the transform function now that accepts a data frame, and it checks if it has to handle NA values, then it's handling NA values the same way, but instead of self.df, you have data frame, and then you have the different encoding types. So if your encoding type is label, then it's going to go through the label encoder's dictionary and then transform each and every value. And similarly, we can do it for binary. So we have binary here, and instead of label encoders, we will be using binary encoders now. Binary encoders.items. But again, we cannot just create like this, because binary encoders has an array. So we need to change this again, val, and then you need to do the same thing that we did here. So I'm just gonna copy this part, I'm gonna paste it here. So what you have, you don't need the output df, obviously. You need data frame, and you need this here, and you need to change this to data frame. Cbin, yeah, now looks good. So why do we have the transform function? Because in case you have a test data set, you need to have a transform function. You don't want to fit on the same thing again and again. And this will transform the data frame, but we also need to return something, return data frame, and here also you need to return data frame. So as you can see, now it's taking way longer, and so I'm going to just stop it. This function is actually working, but I'm just going to stop it, and I'm going to try with head 500 just to make sure that this is working for me, because it's taking way longer than I expected. Yeah, okay, so this works. So you can see you have the ID column, you have everything else, but now we have modified it. So bin0 underscore underscore bin0 and month underscore underscore bin9. So it's like that, and everything is binary. So this works for us, but the thing is, if it's going to take so much memory, if it's going to be so slow, then why should we even bother using it, right? And now we have the next thing that we have to give a try, and that's one hot encoding. But before that, let's see, we just created this transform function, right? And transform function has this label transform, binary transform, and let me make this disappear. And we also have a test dataset in the same competition. We have the test dataset, and I have downloaded the test dataset. It's here called test_cat. Now the problem is I have seen the test dataset, but we are just going to give it a try. I'm going to call it tf_test. This is going to remain the same, and you have output df. Instead of that, I'm just going to call it train df, train_transformed, and test_transformed will be cat feeds dot transform df_test. So in theory, this should work. Let's see if it works. Just going to run the function again. I'm just trying to check if this works. Okay, this works. But there is another problem here. Let me make it label encoding, and let's just use all of the dataset. For all of the dataset, it's quite fast, so it should give me something very quickly. It's not creating any new columns. Label encoding is really fast. So it's working. So now it gives me an error. So we saw this kind of error, y contains previously unseen labels. We saw this kind of error when we have NaN values, right? But in this case, we have entirely unknown categories in the test set. Now to handle it very easily, in an easy way, it's to just combine train and test data frames to one single data frame. So I'm going to say, okay, full data is pd.concat df and df_test. But the thing is, in df test you don't have target column, so we create a fake target and assign it a value of -1. And you also want to keep track of what's in your training data and what's your test data, because you have to split later. So what you can do is you can have train IDs is df id.values and test IDs is df id.values. No, not df_test. So you got train IDs, you got test IDs, and you assigned a fake target to test data. You have concatenated training and test, and instead of df here, we will be using full data, and full data transformed is this. And then you can just do this. So you have train underscore df, which is full data transformed, and inside full data transform you have to take only those IDs which are in train IDX, and then reset the index. True. And you have to do the same for test. So I'm going to say test df will be full data transform ID in test IDX, and then let's just print the shapes of these two. You have to know that you have a fake target column. So when you're building a machine learning model, you need to remove that. Maybe no. I will come to that later. So I have fixed that. And now I'm not using the transform function anymore. I'm just using the fit transform. It's transforming the whole dataset at once, including test one. So we're just going to run it. It's probably going to take a while. Let's see. And it's done. So you have 600,000 in training set and 400,000 values or samples in test set. And we can quickly check that. So I will just count number of lines and train cat, and that's 600,001. So that's one header column, and 400,001 for the header. So that works fine. So now we have a working solution for categorical variables. So we did the binarization thing. We did one hot encoding. We did binarization, but we didn't do it in a very efficient way. So one way of doing it more efficiently would be to not create the columns, but to just stack the binary arrays for different columns together. So that's one more way of doing it. I'm not going to do it in this video, but if you plan to do it, then you can send a pull request to the ML framework repository, and I will merge the best ones. I know I still have to look at the exercises which you guys have done from the previous video. So I'm going to merge all of them together. And that's quite easy. So what you have to do is go to this label binarization, and instead of creating new columns, you just keep track of which columns you saw, and then just stack these values together in a new array, create a new array. And instead of returning a data frame, now you're actually returning a numpy array. So the next thing, we're going to do the same in the third one hot encoding. So in one hot encoding, you're actually creating a sparse matrix. So if you look at that, you have one hot encoder. So okay, this didn't work. Expected 2D array got 1D array instead. Okay, dot values dot reshape -1, 1. Okay. So what one hot encoding is doing, okay, I think I'm going to have the same error here. It apparently doesn't like one-dimensional arrays. No? Fill in. Okay, dot values. Okay, so it creates a sparse matrix. So we don't want to create a data frame of sparse matrix, because you have to you have to make it dense. Then you have a column name for each and every of them, and it's going to use unnecessarily going to use a lot of resources. We don't want to do that. So we are going to create a sparse matrix from the whole data frame. And you see, like in this one, if you supply multiple column names, it should work, right? Hopefully. Okay, bin 0, bin 1. Okay, so needs another bracket here. Okay, so this works like this. So you don't have to fit one hot encoder for each and every column. Let's say this, and we don't need the reshape. I don't need all this. And you have 600,000 by 6 sparse matrix. So you have 1.2 million stored elements. And let's incorporate that in our class. So you have the categorical features class, and then you need self dot one hot encoder OHE. Let me just call it OHE and assign it none because it's just one. And then I'm going to create a new function one hot. So what this does is you were previously going with each and every column name in cat feeds, but now we're just going to use all of the columns. So I say, okay, OHE is pre-processing dot one hot encoder, and you have to fit it. So OHE dot fit is self dot df, and on this you have self dot cat calls. I think that's what I call it. No, cat feeds. Okay, so categorical features. I'm just going to say values, and then return OHE dot transform self dot output df. We're going to use the same features, so this is just a sanity check. Self dot cat feeds dot values, and here you have a sparse dataset returned. And now we need to add this part here. If encoding type is OHE, then do one hot encoding underscore one underscore hot. Let's see if this works for us. You can no longer use these things here. Your ID column is gone. So what you can do is you can do train of length of df and length of df underscore test instead. Change the name a little bit, train len, and okay, test length. You don't even need this. You concat, you have all these columns, categorical and one hot encoding, full data transformed is this one, which is still correct. And instead of train df, you have, don't need all these things. You have full data transformed, all rows, no, just till train len. And here you have the same thing like this. I hope that works. Let's try it. Let's see if that works. I don't know how much time it takes. So it seems to be giving us an error. It has no attribute one hot. Why doesn't it have? We just added it. Okay. Okay, let me make this small. Binary. Okay, so this is not the function. Self dot underscore one underscore hot. It is there. Oh, I call it OHE hot. Let me call it one hot. Let's run it again. So it gives us an error, and we have made a big blunder. So it's telling me that input contains NaN values, and it's in the transformation function. So the big blunder that we have made, and we have made a few different places. So what we do is we always do the transformation on output. So here in label binarization, we are not doing transformation output. So first let's fix that, do the transformation on output, and you can see now in okay, probably no. It's probably an easy way to fix it would be to just use this df everywhere, do transformation on df, do transformation on df, and then here self.df. Okay, copy this, do transformation on df, and we're done. One more thing that you can do is you can just move this from here to here. So if you're handling NA values, you make the copy after that. So this should probably be working fine now. Let's try. I mean, yeah, it seems to be working fine. So you can see now you have 5,724 columns, training and test data. So we're almost done with handling categorical features. But I mean, this is not everything that you have in categorical features, but since we are doing this, I was wondering why not just make a very simple model and try to submit it and see what happens. So we already have the train data frame, test data frame, we have everything that we need. What we want to do is we want to train a simple model. So I will say, okay, my simple model is logistic regression, and I need to import that. Let me make this small for you. Just disappear for now. Okay, so from scikit-learn import linear model, and there is one more thing that we need. I always like it doing this way. You can probably there are many other ways of doing this. So we need a sample submission data frame, because we are just going to check how it performs on Kaggle. uh, a very simple model. I don't expect it to perform very well, so I'm just going to download the sample submission.csv, and let's see if it works. Yeah, okay. And let me just drop it to the input. Okay, I should have sample submission. Okay, I have sample submission here. So I'm reading the sample submission, and now I want to just train a very simple model. So what I'm going to do is I'm not even going to do any kind of cross validation. I'm not going to tune any parameters, and this is not a data frame anymore, so I'm just going to fix the names x and x test. So you have x. Now it's very important to note here that in this whole class we have not changed the order of the training samples. We have not done any kind of shuffling. If you have to do shuffling, do it here right after you read them, because when you combine them and then you're using this to go back to the original order, it's very important that you should keep the order. So you have logic regression now, and then you want to do we fit on x, and my target will be df dot target dot values, and then I just generate the predictions. Clf dot predict underscore proba x test, taking everything for one. So I've already seen the metric of this computation. It's AUC. For AUC, you want to have probabilities for class 1. And then let's see the sample submission file. How does it look like? So you have ID and target. Okay, so I'm going to say, okay, sample dot lock all rows comma target equals this spreads, and I'm just going to save it as a CSV, submission dot CSV, index is false. We don't want the index column. Okay, I'm going to run this and see if this works, and hopefully it should. Let's see that. So going to the terminal. Python categorical. So it worked. It gave me some warning. Total number of iterations reached. Okay, that's fine. I'm not doing any kind of parameter tuning at the moment. I don't care about it. So I have the sample submission file. Sorry, the final submission file. Looks like this. Looks fine to me. Let's try submitting that. So I'm uploading the submission file now. Let's see how it performs. Or maybe we did something very wrong. We don't know, because we are not doing any kind of cross validation at the moment. We are just fitting a model, and it scores 0.78437. Okay, and if we 784, it's quite low. Yeah, okay, so it's quite low, but 78437, so it should be here 100 something rank, which is not bad, to be honest. And this was our first try, right? It scored quite good in my opinion. So there's a lot more things that you can do with categorical variables. So in this video, I did not talk about handling rare values, and we found a way to like counter the problem when you have new categories in the test data set. So they can also be handled in a much better way. And then you have many different other things like replacing categorical variables with their frequency counts, replacing them with some kind of target encoding, which I don't like, to be honest, because it leads to overfitting. But if you do it in a correct way, then it's very useful, brings a lot of value. uh, there are also many other techniques for categorical variables, like feature engineering techniques that I have not discussed. It's all because um, there was less time for this video, and I think covering three concepts is good enough. And there is one more thing called entity embeddings to handle categorical data, which is also quite interesting and it works quite a lot of times. And for me, it always works. So what I'm going to do is I'm not going to skip them, but I'm going to create separate videos, and they will be part of this handling categorical data video series. So in this episode, we are I think we are done. We have seen you can use label encoding, binarization, and you can use one-hot encoding. So we have one thing missing from here, and that's um, one-hot encoding transformation function. So I'm just going to add that. Okay, I say okay, LF. This is OHE one-hot encoding. So if it's one-hot encoding, what you do is you have the data frame, and you just want to return self.ohe. I think I'm calling it ohe. Yeah, which is self.ohe data frame and self.categorical features. So just to ensure that the order is the same dot values, and that's it, you're done. Else raise an exception saying encoding type not understood. So this is the first part of categorical features. There's a lot more cool stuff. It's coming soon. So stay tuned. And if you have any improvements for whatever I have done uh, in this class, then send a pull request. Feel free to send a pull request, and we will merge all the improvements. And if there are some mistakes that I have made, let me know in the comments. If you want any kind of improvements or something, let me know. For this specific part, we have used categorical features encoding challenge 2. So take a look, and stay tuned for the other parts of categorical features. It's going to be amazing. And see you. Bye.